All right, so quick review. Let's find the missing side first. So let's find, I'm just going to put x for a length. So we're finding the length of a missing side in our triangle. Let's put the x here. Let's say this is 63 degrees, and this is 12. All right? So what's the first thing we need to determine? Alice?
Which method you use?
What do you mean by method?
Like so good.
Okay, so let's write that out. And then by method again, what do you mean?
Like which ones you have. So we have adjacent and opposite and hypotenuse.
Okay.
Okay,
so stop for 1 second. So slow it down. Yeah. All right. So she's determining which trig ratio we're using based on the sides and their relationship to the angle. Okay. So this was the angle we know. All right. And then go through your thinking again. If that's 63, this is the opposite side, and this is the hypotenuse. So in relationship to that angle, this is the opposite. This is the hypotenuse. So Ellis decided we're going to use. Which is which ratio? Sine. We're going to use the sine ratio. Sine is the opposite to hypotenuse. Okay? You want to keep going?
After this, can you do one where you don't have the angle?
Yeah, that's what we're going to do next. We're going to do one where we find a missing side. We're just doing a quick review, finding missing side, finding missing angle, and then you guys are going to do some practice today. All right? Okay, so let's set it up, though. What's the next step? Somebody else. How do we set this up in order to solve for x? Yeah, go ahead, Amira. Sine. No, it's always sine and then the angle. Sine 63 equals 12 over x. Okay? Sine of the angle, sine of 63, and the opposite side of 63 is 12. The hypotenuse is x. All right? Now that's just an equation. Sine 63 is just a decimal. It's just a number. So now we solve this equation. How do we solve for x? When x is in the denominator, do you remember what we did yesterday?
Multiply x on each side.
Yeah, I guess you did that. Yeah.
You did that.
Well, yesterday, first what I did is I put it over 1. And then I did a proportion.
Oh, yeah.
So what you're saying is you multiply both sides by x. The x's will cancel out here, and then you have x times sine 63, and then you're going to divide by that. So that's the same thing. Yeah. So what happens is we get x times sine 63. If you multiply this side by x, this is what you get. If you multiply this side by x, you just get 12, right? Because the x's would cancel. And then we're still getting x by itself. So now how do we get x equals something? How do we get rid of the sine 63? What's that? Yeah, just divide. It's x times sine 63. So now we're just going to divide both sides by sine 63. And then this is what we're punching in our calculator. X equals 12 divided by sine 63. And now we use our calculator, making sure it's in degree mode. Punch this in. What do we get? We got an answer? Come on, I don't have a calculator. All right, you guys find one? What do you get? 13.4. I got confirmation on that.
Hold on.
Stephen, good? 13.4. Yep. Okay. We got 2 confirmations. That's good. All right. All right. Next one. We're going to find a missing angle. So this is finding a missing side. Figure out what trig ratio you're going to use. Set up the equation. Solve for x. It's kind of the same, but it's beginning to find an angle. But then the final answer is a little bit different because we're not using just sine, cosine, or tangent. We're using what when we find an angle? What are we using in our calculator to find an angle measure? What are we? What?
Second.
Okay, a second sine, second cosine. It's what happens? What does second sine do? Look on your calculator. Okay, and which is the inverse sine, right? Okay, yeah. So if it was sine, that's what you would be using. If it's cosine, let's first determine which one we're going to do. All right. So now here's our triangle. Okay. This is 5. This is 15. This is the angle we're trying to find. Find measure of angle theta.
Why do you use theta?
That's what they use, right? That's what, remember? This is the Greek symbol. Okay, it could be an A there, whatever. We're finding that angle measure. Okay? So, Ivan, que paso? You still got swimming? Yeah? They let you in late or out late? How is swimming? Is the pool cold? When you jump in, are you like, this sucks?
No.
No?
Imagine how nice that feels.
It feels good?
Oh, what?
Well, when it's hot outside,
Oh,
the first thing in the morning, I don't know how good that feels.
Alice
First
is a
period.
maniac.
How do
She
you,
likes
um,
swimming.
How do you do it if like it's telling you to solve for a sine
That's what we just did.
without the angle? That's the example.
Oh, you do the Pythagorean theorem. Okay, so Alice is bringing up a good question here. Okay, now this is trig. This is when you have an angle measure in one side, and you can find the other missing sides by using trigonometry. What happens if you have two sides in a triangle? How can you find the third side? Yeah, you can use the Pythagorean theorem. That's what we did last unit. Okay. Now, if these angles were different than 63, if the angle was 60 degrees, then you know it's a 30, 60, 90 triangle. You could still use trig. We did that example yesterday. Or you can use your 30, 60, 90 ratios. Or with the 45, 45, 90 triangle, you can use your 45, 45, 90 ratios. Okay. So use trigonometry when you have an angle measure in one side. Then you can use that information to find the other side. Or we can use trigonometry when we have two sides and we're looking for an angle measure. That's what we're doing here. Yep.
So when you do, when you plug it into the Pythagorean theorem, do you have to square it, or is
Yeah,
it?
it's a squared plus b squared equals c squared. Yes.
So you square it, or is that like the squared version?
No, you have to square all three sides. So that square root of 5 there becomes a square root of 5 squared. Some people did that on the test too. Like when we were checking to see if something was an obtuse, acute, or right triangle, people just like wrote a plus b equals c. It's supposed to be a squared plus b squared equals c squared. What happened to the squaring? Somebody's like freaking out. Yeah. You'll see. You're gonna get your test back in like 3 minutes. Let's finish this one. All right. So first thing we're doing again. What's the first thing we need to determine? Okay. What method? What trig ratio are we using? So in relationship to this angle, what are the sides that we know? That's opposite. This is adjacent. This is the hypotenuse. We don't know the hypotenuse. So we can throw that one out. We can throw that one out. We're going to use tangent. Now, you could do the Pythagorean theorem and find the missing side, and then use that side. Okay, but why do extra work? We already have those two sides. Let's use tangent. Tangent. Now we set it up the same way. Tangent of the angle equals opposite over adjacent. So theta is our angle. And now this is what we're punching in our calculator. Inverse tangent, 5 divided by 15. Theta equals 18.4 approximately. Okay. 18.4 degrees. I got confirmation on that, or I got it. We good? All right. Okay. Yeah, I'll show you on your calculator in a second. All right. Okay. I'm going to hand back your test. So in our packet, what pages did I say again? So the practice problems are on page 5, 6, and 7. All right. You guys can get in like little your little small groups or work with a partner and work on these, and then I'll walk around and help. I'm going to hand back your tests. You can go over the questions on the test in your group, but I'm going to recollect those at the end of the